Hello friends, welcome to Shiksharthi. In this session, we'll be talking about quadratic expressions. So, taking the discussion forward, if you recall in my earlier video, I had talked about if I write a quadratic expression as ax square plus bx plus c. So point number 6 talks about the same expression written in a different manner. So what I have done here is ax square, I have taken a as common. So when I take a as common, I can write down the same expression like this, which is just like saying a times of x square plus b by ax plus c by a. This is another format or another form of writing the same quadratic expression. And the same quadratic expression here is, we are talking about ax square plus bx plus c. Okay. Now taking it to point number 7. So in point number 7, what I have done here is, if you recall, if I talk about a quadratic expression, which we have already talked about, wherein we said what? A quadratic expression, if I assume that it is x square, right? So in that case, I can write it as x into x, meaning thereby I can write a quadratic expression as a product of two factors. And here I have assumed the factors as x minus alpha, one of the factors, and the next factor here is x minus beta. Another way to understand here is I have taken alpha and beta as the factors, and when I write it, I will write it as a times of x minus alpha into x minus beta, where I have taken alpha and beta as their factors, right? So now the next part here is, I can further divide this into two cases, wherein one case is I can take both the factors as equal, and the second case is where both the factors are not equal. Now in case both the factors are equal, and if somebody tells me that there is a quadratic expression wherein both the factors are equal, how will you write that quadratic expression? So you can simply write it as a times of x minus alpha into x minus alpha, which can be written as a times of x minus alpha into x minus alpha, which is nothing but a times of x minus alpha whole square, right? And had both the factors been different, then the quadratic expression remains like this. Okay. Now taking it to the next point, which is point number 8, and here now we are talking about various concepts. We have already talked about the basics earlier with some concepts, and now here again we are talking about further concepts. So if I expand this, I can expand it like a times of x square minus x times of alpha plus beta, where alpha and beta are the factors, plus alpha into beta, right? Now if I want to compare point number 6 and point number 8, I get point number 9. So when I am comparing these 2 points, what will I get? I have to just compare their coefficients. So ax square is equal to ax square, right? The coefficient of x here is b by a, and the coefficient of x here is minus times of alpha plus beta. When I compare these, now when I say compare these, that means I'm equating them. I'm equating this to this. So in that case, equate means what? Put an equal to sign in between, right? So which is just like saying from here you are able to deduce the formula. And which formula am I talking about? The sum of the roots. So let's say that sum of the roots, I'm denoting it by an S, and the product of the roots, I'm denoting it by a P. So the sum of the factors here, because I would use the terminology roots only when the quadratic expression is equated to a 0. So coming back, the sum of the given factors here would be how much? Alpha plus beta, which is nothing but minus b by a. And the product is nothing but alpha into beta, which is c by a. Taking it forward, now if I combine everything that I have discussed till now, I'll be able to say, if I know the factors, right? Please mark the words being spoken. If I know the factors, naturally I can find out their sum. Okay. If I'm able to find out their sum, can I write down a quadratic expression? Yes, I can write it down. And the quadratic expression will be written as a times of x square minus s, where s signifies the sum of the roots, times of x plus p, where p is the product of the roots. I'll just take a very small example for this. Now, if somebody tells me that 2 and 3, which is just like I'm talking about this case, and one case is I'm talking about 2. So I'm talking about this case. So if somebody tells me there is a quadratic expression having both the factors as 2, there is a quadratic expression which is having both the factors as 2, write down that quadratic expression. How will I write it down? Now I know that alpha is equal to beta is equal to 2. In that case, I will simply write it down as a times of x minus 2 whole square, just related with this formula that we had discussed. Similarly, if somebody tells me that there are two factors of a quadratic expression and the two factors are 2 and 3, so write down a quadratic expression which has the factors as 2 and 3. So all I need to do here is I can just simply use this formula, right? Or I can use this formula. So now when I write down the quadratic expression, can I say it will be nothing but x square minus 2 plus 3 is 5 and 2 into 3 is 6. Keeping in mind that a will not be equal to 0. So what is the value of a if it is not equal to 0? A can be any number. When I say any number, it can be a real number also, it can be a non-real number also. That is not the point of contention. The point of contention here is a should not be equal to a 0. I hope it is fairly understood. Right? Last but not the least here, if the same discussion I had to combine, I mean whatever, all the point number 1 to point number 10 that I have discussed till now, I would say that if the same discussion I had to relate it with equations, quadratic equation. So quadratic expression comes first, followed by quadratic equation. So any quadratic expression when equated to a 0 becomes a quadratic equation. Now in that case, everything remains the same except for the terminology that you are using. One is expression and equation, and then in expression we talk about factors, but in an equation we always talk about the zeros of the polynomial or the quadratic equation, or we talk about the roots. That is the only difference. So if you master expressions, equations are already mastered. Yeah. If you feel that this session has been really informative, please do not forget to like, share and subscribe to our channel. If you have already done so, please click on the bell icon and select all so that you start receiving updates from us, because every new video posted, you'll start getting updates. Thank you so much. Until next time we meet, goodbye.